This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the October-November 2021 Cambridge 9709 International A-Level AS paper. This is paper 1, variant 3, the pure mathematics paper. This question here is about trig identities and equations. So we're going to start off with this question where they're asking us to show that this equation, so we have been given an equation, tan x plus cosine x divided by tan x minus cosine x equals k, can be rewritten or can be expressed in another way as k plus 1 sine squared x plus k minus 1 sine x minus k plus 1 equals 0. So this equation, which is tan x plus cosine x. Now, what I'm going to do to make it a bit easier is instead of writing it as divided by as a fraction, I'm going to write divided by with a division sign, which is the same thing. Divided by tan x minus cosine x is equal to k. I want to rewrite this such that it's going to end up looking like that. Right now, with these type of questions about trig identities, we have to be very, clear in our thought. Don't expect to see the whole path ahead of you and think that you will be able to see exactly what you need to do from the beginning to the end when you start these questions. Okay, don't ever think that you will be able to see the whole path ahead of you, right? You take it step by step, but you keep the goal in mind. You keep the goal in mind, all right? So for example, here we see we're going to end up with everything just dealing with signs. So we're going to think of how can we change things such that we'll end up with sine, for example. That's one of the things that we'll see on the way, right? Now, in terms of the first step, there's not much we can do. There's two main identities, fundamental identities that we need to know for us to be able to answer this question. And these identities are given to you in the Cambridge formula sheet. But by now, they should be engraved into your brains. And one of them is that if you have an angle and the sine of an angle and you square it, and you add to that the cosine of the same angle and you square that, you will always get 1. Sine squared of any angle plus cosine squared of that same angle will always give you 1. Now remember, sine squared just means, sine squared theta just means sine theta squared. You don't square the angle, you square the ratio. Okay, so that's one identity, very, very important identity, which you're going to use again and again throughout your trigonometry life. And the other one is that the tangent of any angle is equal to the same ratio as the sine of the same angle over the cosine of that same angle. Okay, these two identities, all right, are very important for us to know. In Cambridge, you don't have to memorize them, but they should be by now engraved into your brain. If you've been doing lots of work of trigonometry over the years. So over this year, when you started your AS, that should be engraved into your brain. Now, so there's not much we can do with this right now, except for use this identity here. We can change the tan x to sine x over cosine x. So the tangent of the angle x is the same as the sine of the angle x over the cosine of the angle x, plus cosine x divided by, and I'll do the same thing here, I'll change the tan x to sine x over cosine x minus cosine x equals k. Now, with these questions where it says show that, and they're giving you exactly what you have to show, you have to be very, very careful to show your steps very, very clearly. Okay, don't just jump things, because they're giving you exactly what you have to show. So they'll expect you to show, proper steps on the way. So the next issue now is to try to simplify this and in the end end up with just things involving sine. So if you have something like this divided by something like that, what would make life easy for us is if we express these as a single fraction, and then we can divide them easily. That will make the division easy. So what I'm going to do now is I'm going to write these as one single fraction. So I'm going to have a common denominator of cosine x. Now for this to become cosine x, okay, I'll put it in a different color so it's clear that we did that afterwards. So for this to become cosine x, we have to multiply the denominator, which was 1, by cosine x. So we multiply the numerator also by cosine x, so it becomes cosine x squared. Okay? And the same thing over here. This is a 1 right now. We want to make it into cosine x, so we multiply the denominator by cosine x. Therefore, we multiply the numerator also by cosine x, so it becomes cosine x squared. Okay? Which is the same as cosine squared x. So now I'm going to write this as this, the sine x, this part stays the same, plus this becomes cosine squared x. Remember, they mean the same thing. Okay? Divided by, and now we're going to have this single fraction, one denominator of cosine x, and that's going to be sine x minus cosine squared x equals k. So now what I can do is I can move this up here. Now what I can do is I can actually divide them. Now remember, when you're dividing two fractions, you change this into a multiplication sign, and the fraction afterwards becomes its reciprocal. So you have sine squared x plus cosine squared x over cosine x times, so that becomes times, and this one you flip it over upside down. It's KCF, as you remember from primary school, cosine x over sine x, not sine squared, sine x, be careful, sine x minus cosine x, cosine squared x equals k, right? So now we can see that these will cancel out, and we're left with, sorry here, guys, careful. This is sine x, not sine squared x. You have to be really careful not to make silly mistakes like that. Sine x plus cosine squared x over cosine x times cosine x over sine x minus cosine squared x equals k. All right, so now what we have here is something where we can basically do what here? We can write it as sine x plus cosine squared x over sine x minus cosine squared x equals k. So now I want to get rid of the fraction because we don't want to have any fractions. We're going to end up with something, there's no fractions in it. So I'm going to multiply both sides by sine x plus cosine squared x. Okay, so I'll multiply both sides by sine x minus cosine squared x. So I'll multiply this side by sine x minus cosine squared x. I'll multiply this side also by sine x minus cosine squared x. Some people think of it as cross multiplications. They cancel out here, and I'm left with sine x plus cosine squared x equals k times sine x minus k times cosine squared x. So I've just expanded that bracket. So now I'm left with this expression here, which I can now try to simplify. Okay, so now I keep in mind our answer. Our answer has everything involving only sines in it, no cosines. So I know the identity sine squared theta plus cosine squared theta equals 1. So if I want to replace cosine squared theta and replace it with something in terms of sine squared theta, okay, I can say that cosine squared theta is 1 minus sine squared theta. So in this case, I can say this is going to be sine x plus 1 minus sine squared x equals k times sine x minus k times 1 minus sine squared x. So now we've got to the objective where we have everything in terms of sines. No cosines, no tans, sines. Now we have to rewrite it so it says equals 0. Okay, so I can see here that I'm going to, let me just expand this first. I'll have sine x plus 1 minus sine squared x equals k sine x minus k plus k sine squared x. So what I'll do is I will make this side into 0 by getting rid of these terms. So I've got my k sine squared x. So I'll write that first. K sine squared x. Now I want to get rid of this minus sine squared x from this side, so I'm going to add sine squared x to both sides. So it'll end up as k sine squared x plus sine squared x. Then on this side, I've got plus k sine x. I want to get rid of this sine x. I'm going to subtract sine x from both sides, so I'll put minus sine x. And here I've got negative k. And I want to get rid of this plus 1 from this side, so I'll subtract 1 from both sides. So I'll end up with this. Now I can see here that this sine squared x is a common factor of these two terms. So I can write it as sine squared x times k plus 1, right? And in these two terms here, I can see sine x is common. So I'll put plus sine x times, that's going to be k minus 1. That'll be k sine x minus sine x. And then I've got this. Now I want to end up with minus k plus 1 in brackets, which is exactly what will happen if I take minus 1 out of these two. I'll have minus 1 times k plus 1, which is minus k plus 1 in brackets. And now that's equal to 0. I've just written this the other way around. Okay, that's equal to 0. Now I've got exactly what I need. I'm just going to write it in the same form. So I have k plus 1 times sine squared x. Just write it the other way around. Plus k minus 1 times sine x minus brackets k plus 1 equals 0 as required. Okay, so there is exactly what we had to show. K plus 1 sine squared x plus k minus 1 sine x minus in brackets k plus 1 equals 0. So there's the answer to this question. So even though we could not see every single step of the way, we don't need to do that. Okay, so don't ever think that, oh, I don't know how to do, this question because I can't see exactly what to do every step of the way. Don't worry about that. What you need to worry about is basically just taking things step by step, but keeping the goal in mind. Keeping the goal in mind, right? So we know we have to end up with everything in sine. The first step, we can just change tan into sine over cosine. Then not much we can do except for let's put the fractions together. Let's actually divide the fractions. And then you can see you end up with something which we can deal with. It ends up with cosine squared x's, which we can change into in terms of sine x by using this identity. And then we get to our answer in the end. And, it's not that difficult. A lot of people get problems with this topic because they think they should be able to see the whole picture ahead of them, but you don't have to. Okay, just keep the goal in mind and just do what you have to do to get there. All right, now for part B, it says, hence solve the equation tan x plus cosine x over tan x minus cosine x equals 4 for x between 0 and 360 degrees. Now this stuff here I brought up from the other page because I don't want to have to keep going back and forth. But basically when it says hence, whenever you see a question that says hence, it means using what you just found. So we're using this fact that we just proved. Now, whether you proved it or you were able to prove it or not, we can still use, the fact that this can be rewritten in this form, okay? And that's what's going to help us solve this equation, all right? So don't ever think that, oh, I can't see how we got there. Don't ever think that. Therefore, I can't answer part B. No, you can use the answer to part A, even if you don't know how to do it, to answer part B. You just have to rewrite this in this form. So if we look at this, we can study, this is 4, okay? This is 4 here, and this is K. So in this case, K is equal to 4, right? So K in this case is equal to 4. So we can just replace the K with 4. So you're going to have 4 plus 1 times sine squared x plus 4 minus 1 times sine x minus 4 plus 1 times just 4 plus 1 equals 0. That's going to give you 5 sine squared x plus 3 sine x minus 5 equals 0. So now we have to solve this equation. Now to make it more familiar, so it's like something that you can, picture, we're going to think of this as a disguised quadratic. You don't have to do this, but this makes life easier. So for example, let u equals sine x. That means u squared is going to be sine squared x. So we can now replace the sine squared x with u squared and the sine x with u. And we have this equation. Now, to solve this equation, let's see first, are we able to factorize it? So I'm going to just have a quick look at that. If we can factorize it, we'll factorize it. If not, we can use the formula or completing the square. So I've got 5u squared on the top left, and I've got minus 5 on the bottom right. So I need two numbers that multiply to give me minus 25u squared. And their sum has to be plus 3. It doesn't look like it because the only way they're getting 25 is 25 times 1 and 5 times 5. There's no other way of getting 25 as a product. So there's no way you can get something which has like a difference of 3. So this can't be factorized. So we have to use the quadratic formula. Now the quadratic formula, in this case, is going to be u equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Again, this formula I think is given to you in your Cambridge syllabus, but by now, since grade 7, 8, it should be engraved into your brain. But here, we know we need to now to apply it. So a is 5. Quoting the formula is not enough. You have to show that you have solved the equation either by factorizing, by the formula, or completing the square. Completing the square here is going to be a bit more complicated, so I'm going to use the formula, makes life a bit easier. So a here is equal to 5, b is equal to 3, c is equal to negative 5. So we can say u is equal to minus b, which is minus 3, plus or minus the square root of b squared minus 4ac. So you're going to have 3 squared minus 4 times 5 times minus 5 all over 2a all over 2 times 5. So you're going to have u equals minus 3 plus or minus the square root of, that's 9, that's going to be plus 100, 109 over 2 times 5, which is 10. It's 20 times 5, 100 plus 9, that's right. Okay, so now we can find the values of u. So let's put that down here. So we can say u equals, so now I can use a calculator. Just in case I made a mistake somewhere. Just in case I made a mistake somewhere, I can do this. Minus 3 plus the square root of 3 squared minus 4 times 5 times minus 5 over 2 times 5 minus 3 plus root. Yes, so we're going to have this answer here. So that's going to give us what? The decimal 0.74403, 0.74403, dot, dot, dot. And the other value of u is going to be, when you put a minus instead of the plus between them over there, plus or minus. Now that gives us negative 1.344, negative 1.344, which of course it won't lead us to any solutions here. So now we know that sine of x equals 0.74403, and the sine of x equals minus 1.344 dot dot. Now this will have no solutions, because as we know the sine curve, if we were to just make a sketch of the sine curve here just to illustrate, between 0 and 360, the sine curve has this type of shape. Okay, it goes up to 1, down to 0, down to minus 1, back to 0 again. It never ever goes above 1. It never ever goes below minus 1. So this is out of range. Minus 1.344, it will never reach that. It will turn up before it gets there. So this is going to have no solution, but this one will be a solution somewhere over here. That will be one of the solutions. So let's go back to the calculator and get back to this answer here. Yeah, I'm going to save this answer as A, actually, just to, so I'll store it. Sorry, I'll store this as A. Okay, so this is answer A now. Okay, why? Because I'm going to check with things later on. So now I'm going to find the inverse sine of this. So to find the angle, I need to find the inverse sine of the ratio. And I'm going to use what's in my calculator to find that, to make it more accurate. So I'm going to say inverse sine of what we called A. Okay, which is going to give me 48.0759. 48.0759. All right. And I know that, as we can see from the sine curve, if this is, for example, 0.7, whatever we had there, there's another place where you get this, you get an angle which shares the same sine ratio, which is over here. Now, how are these two places related? Well, this distance is 48.0759 away from 0. And this is that same distance because of symmetry, less than 180. So the other angle is 180 minus 48.0759. So 180 minus 48.0759. And that gives us the other angle. So I'm going to take my answer here. I'm going to do 180, take away the answer, and that gives us my other answer, 131.924. 130, got already, silly me, 31.924. 924 degrees. So now in the end, we want to write our answer in the correct format. The questions always tells us to write the final answer. If it doesn't tell you otherwise, at the beginning of the paper, it tells you to write your answer to 1 decimal place for angles in degrees. So it's 48.1 and 131.9. Those are the answers correct to 1 decimal place, as we are supposed to write unless otherwise stated. Angles in degrees to 1 decimal place. Okay, so there's the answer to part B of this question. Okay, and we, finished. If you wanted to check your answer was correct, you could basically take, let's say we go back to our previous answer. Okay, and let's say I store this as C. Let's say I store this as B. I could check over here in the equation, okay, that we had, which was 5 sine squared x plus 3 sine x minus 5, and check if it gives us 0. So if I do 5 times, and I'll put in brackets, sine of C, did I put it as C? Let me just make sure, one second. As B, I think I put it as B. No, I didn't. What do I do with it? Okay, let me do this. Inverse sine of the answer gives us this angle. So I'm now going to store this as B. Okay, so now if I do, so I know that B is that. So if I press alpha, B, it's going to give me, yeah, okay. So now if I do 5 times, so 5 times in brackets, the sine of B squared plus 3 times the sine of B, which is the angle that we've got there, minus 5. This should give us 0. And it does. So we can be sure that we have got the right answer. That's a way to check your answer. All right, so that's really should be done if you have time at the end of the paper, if you want to be sure. But that's one way of checking. So there we have the answer to this question. Other questions from this particular paper, October, November 2021, can be found in the playlist that will appear in this section over here. Other questions from this topic of trig identities and equations from P1 of Cambridge can be found in the playlist over here. I'll also include my material from P1, P2 of Edexcel, which is basically the same kind of material, just almost the same, just more, you can see more questions on it from this playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.